All right, so let's do some practice. So we learned how to do these calculations for expected durations, variances, etc. Now we are given the following. This is a PND which consists of three paths: A, B, C, D, E, F, G, H, I, and on the top of every activity you can see three numbers, and you can guess what are these three numbers. Here, by the way, I don't need to tell you, for example, for activity B, I don't need to tell you that activity B has a optimistic time of 2, pessimistic of 6, and most likely of 4. I will simply give you these three. And you should guess that 2 is the optimistic, 6 is the pessimistic, of course, and 4 is the most likely. All right? And by the way, the most likely does not need to be equidistant between the optimistic and the pessimistic. For example, here, look at this. 3 is not, or the difference between 3 and 2 is not the same as 3 and 5. So it's not the case. Okay. But what's always the case is that the most likely is the value between the pessimistic and the optimistic. All right. So the question here, find the expected duration and the standard deviation of each path. And these two values are very important for our ultimate objective of the analysis under uncertainty. And I'm going to show you later why these are very, very important for our analysis. But now let's do these calculations on the next slide. All right, so here I set up a table because I prefer to do my calculation in a tabular form. It keeps everything neat and well organized, very clear. So you can see that in what you can see here is all given. So we have the three paths, A, B, C, D, E, D, F, G, H, I, and I have a list of each activity. Then for every activity, we are given T, O, T, M, and TP. So these are all given. Okay. Now I have two blocks. The first one is the activity duration, and you will see later what I'm going to do. So now that I'm given for every activity these three time estimates, what I can do, I can find the expected duration of the expected value of the activity duration. All right. So this is what I'm going to show here. So remember, what was it? TE is equal to TO plus 4TM. So that's 4 times 3, 12 plus 1, 13 plus TP, so plus 4. So that's 17 divided by 6. Okay, and you will get, the second one is the variance. But now let's go back here. It will be 2.83. All right. Now let's find the expected duration for the second activity. It's 2 plus 6, 8 plus 4 times 4, 16 plus 8, 24. 24 divided by 6, that's 4. Then for activity C, it's 2 plus 5, 7 plus 4 times 3, 12 plus 7, 19. 19 divided by 6, that would be 3.17. Now let's find the variance of the activity duration. All right, remember the activity duration is a variable. For example, x, call it x. It's a variable that has a mean and it has a variance. So let's find the variance of this one. What's the variance? It says TP minus TO squared over 36. So 4 minus 1, 3 squared, 9 over 36. 9 over 36, 0.25. Second one, B. It's 6 minus 2, that's 4, squared, 16 over 36, 0.44. Then 5 minus 2, that's 3, squared, 9 over 36, that's 0.25. All right, so I believe these are clear enough, and I strongly advise you to do yourself these calculations for DEF and GHI, but here are the results for you. But I strongly advise you do it first and compare your answers to these values. Okay, now that we have found for every activity what's the expected value, what's the expected duration, what the variance of this duration, Now I'm able to find the path duration metrics. What are they? First, I need the expected value of every path duration, and I need the variance, not because I like the variance, but because ultimately I need the standard deviation of the path duration. Again, for reasons that I will clarify later. But I have already explained for you why I need first to find the variance and then move on to the standard deviation, because I cannot sum up the standard deviations of the durations. I can sum up the variances of the durations and then find the variance of the path and then square root it to find the standard deviation. All right, now what's the expected duration of the first path? It's very simple. It's equal to the sum of the expected duration of the activities in that path. So you sum up these three, all right, which comes to 10. What about the variance of this path duration? Also very simple. Simply sum up these and you will get this. Standard deviation, simply square root of 0.94, so 0.97. Now I'm going to show you the answers for the two other paths, and here we go. All right, so these calculations will be the foundations for our analysis that we're going to do next.